In this third episode, we are going to use the U substitution method in order to evaluate integrals that will lead to inverse trigonometric functions. So let's just recall the U substitution. If you have an integral of f of g of x multiplied by g prime of x dx, then this is the same as integral of f of u du, where we have used the representation g of x equals to u. We will also list three integrals that will lead to inverse trigonometric functions. The first one is integral of du divided by a squared plus u squared. A here is just a constant. This will be equal to 1 over a tangent inverse of u over a plus a constant c. Now, if you have integral of du divided by square root of a squared minus u squared, then this will be sine inverse u over a plus c. While if you have this variable and constant switch in the denominator, and you have u multiplied in the denominator, this will be 1 over a secant inverse of the absolute value of u over a plus c. Let's consider the first example. So we have here a, which is actually the integral of dx divided by 4 plus 9x squared. Take note, we can rewrite this one as the integral of dx divided by 4 is just 2 squared plus 9x squared can be written as 3x raised to the second power. And let's recall the formula: integral of du divided by a squared plus u squared. This is equal to 1 divided by a tangent inverse u divided by a plus the constant c. Looking at our example, our a here is just equal to 2, and our u, we can let it to be 3x. Now du here will be 3 dx, or we can divide this by 3 and get du over 3 is just equal to dx. Now using this information, we can now rewrite this integral as, well, dx now will be replaced by du over 3 divided by, well, this is 2 squared plus the 3x now will be replaced by u, and this will be raised to the second power. So this will be 1/3 of the integral of du divided by 2 squared plus u squared. And in this case, we can see a very similar pattern in our integral. So evaluating this integral using the formula, we will get 1 divided by a, where a is just 2, times tangent inverse u divided by a, which is 2, plus c. Now simplifying this further, we will get 1/6 tangent inverse. Our u is just 3x, so we just have to replace it by 3x divided by 2 plus c. For letter b, we have integral of 5 dx divided by 1 plus 3x squared. We can rewrite this as 5 integral of dx. Note that we can write the denominator as 1 squared plus square root of 3x raised to the second power. And in this case, our a is just 1, and our u, we will let it to be square root of 3 multiplied by x. And therefore, if we take the derivative both sides, this will be du, and this will be square root of 3 dx. Now what we need here is just dx, so we can divide both sides by square root of 3. So this will be du over square root of 3 is equals to dx. Rewriting now our integral, this will be 5 multiplied by dx. Well, dx is just du divided by square root of 3. Everything is divided by 1 squared plus, well, square root of 3x is actually u, and this is raised to second power. Now we can move the square root of 3 outside, so this will be 5 divided by square root of 3 multiplied by the integral du divided by 1 squared plus u squared. And we can see now the pattern from our formula, and evaluating this integral will give us 1 over 1 tangent inverse of u divided by 1 plus c. But rewriting this one will give us 5 divided by square root of 3 tangent inverse. Our u is just square root of 3x plus c. Let's consider our second example. For letter A, we have integral of 3 dx divided by square root of 25 minus x squared. Now we can move the 3 outside of the integral, so our numerator here will just be dx. Our denominator can be written as 5 squared minus x squared. Recall that if you have square root of a squared minus x squared in the denominator, we have the formula integral of du divided by square root of a squared minus u squared. This will be equal to sine inverse u divided by a plus c. So in this case, our a is just 5 and our u is just x. So du is just equal to dx. Rewriting this integral now, we will get 3 multiplied by integral of du divided by square root of 5 squared minus u squared. Now looking at our formula, we can evaluate this integral now as sine inverse of u divided by a, but a is just 5 plus the constant c. Finally, we can simplify this to 3 multiplied by sine inverse u is just x divided by 5 plus the constant c. For letter B, we have integral of e to the x dx divided by square root of 1 minus e raised to 2x. Note that we can rewrite this as e to the x dx divided by square root of 1 squared minus e raised to x raised to 2. And in this case, our a is just 1. We can let our u to be e to the x. And when we take the derivative on the left side, this will be du. The derivative of e to the x is still e to the x, and we just put dx. Note that this is the same as the numerator. So we can rewrite now our integral as du divided by square root of 1 squared minus, where our e to the x is just u raised to the second power. Looking again at our formula, we will now have sine inverse of u divided by a, which is 1, plus c. Or we can rewrite now this as sine inverse of our u is e to the x plus c. Finally, we have integral of dx divided by 2x multiplied by the square root of 4x squared minus 9. Take note here that we have x multiplied to the square root in the denominator. So this leads us to the formula integral of du divided by u multiplied by the square root of u squared minus a squared. Take note the u here comes first inside the square root. And this is equal to 1 over a multiplied by secant inverse of the absolute value of u divided by a plus c. Now first, we have to rewrite our integral. We can move the 1/2 outside of the integral, and this will be integral of dx over x times the square root of 2x raised to the second power minus 3 squared. And in this case, our a is just 3. Our u is just equal to 2x. Taking now the derivative both sides, we will get du equals to 2 dx, or we have du divided by 2 is equals to dx. Also, we need to replace the x here, but from our representation u is equal to 2x, we can divide both sides by 2, so we will have u divided by 2 is equal to x. Now let's use this information to rewrite our integral as 1/2 times the integral of, well, dx now is du over 2 divided by x is actually u over 2 times the square root of 2x is just u, so this will be u squared minus 3 squared. Now we can cancel the 2 here, and we will get 1/2 times the integral of du divided by u times the square root of u squared minus 3 squared. Now this integral is in our desired form, so we'll just copy 1/2 times, using that formula now we will have 1 over a, which is 3, times secant inverse of the absolute value of u divided by a, which is 3, plus the constant c. Rewriting now this answer, this will be 1/6 secant inverse of our u is just 2x divided by 3 plus c.